Alright, so we're looking now at the pendulum one now for the next one. So there was only one formula for the pendulum. T equals 2 pi root L over G. Okay. Right, so here I have my pendulum. The length was 0.82 meters, and then the amplitude here I said was 35 millimeters, so it's 0.035 meters. Question 1a is what's the time? So the formula is just 2 pi root L over G, which we did in the last class. So 2 pi root L over G. So the time here is 1.82 seconds. B, what's the maximum velocity? So the formula here is velocity. What's the formula for velocity? Come on. A omega sine omega t. Now, if you look carefully at this, you can break it into two parts, A omega and sine omega t. Does anybody know what is the maximum sine omega t can be? What's the biggest this could be? Does anyone know? What's the biggest value that this part could be? What's the biggest number this could be? No? No? Anybody? What's the biggest this could be? The maximum of this part is... Anybody? Come on. Somebody knows this. I know they do. Sine omega t, what's the biggest it can be? Nobody? 1. Sine is never more than 1. You can check it on your calculator. No matter what angle you put in, your sine is never more than 1. Now think about it. Look up here. What's the formula for sine? Opposite over hypotenuse. Yes? Opposite over hypotenuse. The hypotenuse is always the biggest side, true? The hypotenuse is always the biggest side, which means this piece is always smaller than this piece. So the most this could be is 1.
Which one is equal?
1 is when they're actually equal. Yeah. So that just takes me to my point. The formula for the maximum velocity is just A omega. That's the biggest the velocity could be. So do I have my omega? No, I don't. I need to calculate it. So my omega is 2 pi over t. (0.035). My omega was 3.46. Well, 458. So the maximum velocity is 0.121 meters per second. Now, does anybody know when this maximum will happen? At what point? Yeah, when it's hanging down here. When the pendulum is at its lowest, this is when the ball is going at its fastest. So, at the lowest point. Okay, maximum acceleration. So what's the formula for acceleration? Minus omega squared X or S, whatever. Now I definitely hope somebody can tell me this one. What is the maximum the X can be?
0.
No, the maximum.
An amplitude?
Correct. Is the amplitude. That's the biggest X can be. So we get this formula now. A max equals minus omega squared. And we're not too worried about the minus because we want as a maximum. So the maximum it can be as a positive is 11.96, so that's 12 meters per second squared is the biggest it can be.
Why is it just minus?
Oh, sorry, you're right, I'm being stupid. I forgot my A. So I forgot to put the A in here. So when I multiply this by A as well, sorry, the maximum will be 0.419 meters per second squared. Okay. E, when will the acceleration be maximum? Yeah. When will this be maximum? When will this happen? When the pendulum is swinging, when will the acceleration be maximum?
When it's at straight?
Nope.
When omega maximum and x maximum.
Yeah, when? When?
When frequency is long.
When velocity is constant.
No. At the beginning. Because remember, F equals ma. Now look at me. F equals ma.
Mm-hmm.
So the A is maximum when the F is maximum. And the F is maximum in simple harmonic motion whenever you're furthest from the center. Because the further you are from the center, like with a spring, the more force you have. So the more you move the pendulum up, the more force it will have moving towards the center. So at the top, either side. So at the highest point. Okay, so F now is they want an energy graph. So here is X, and here is at the amplitude, and here's at minus amplitude, and then here is the energy. So at the beginning it has maximum potential at the beginning. And then at the lowest point here, it has no potential. You've seen this graph already, I did it in class. And then at the beginning, it has no kinetic, but then it gets kinetic as it moves towards the center, and has maximum kinetic here. And its energy is constant always. So I write TE for total energy. So that's what the graph looks like, but we did that one in class. So in G, I give you the mass, and I want to know how much energy it has. So here, the energy in total, that could equal the energy at the start, or it could equal the energy at the middle, or it could equal the energy at the end. It doesn't matter, because the energy is the same. What would be the most convenient point to use? Should I use it at the start, the middle, or the end?
Doesn't matter.
Yeah, but which is most convenient? The start like this, the middle, or the end?
The middle.
The middle, why?
It's not that
The middle is most convenient because
yeah.
I already know its velocity at the middle. So if you think about it like this, when the pendulum is here, what energy does it have? It only has kinetic. But here it only has potential. But because I know the V already, I'll look at it here. The total energy is equal to the energy in the middle, which is equal to only kinetic energy, which is a half mv squared. And I know the V already. The V I said was 0.121. So the total energy is 3.29 times 10 to the minus 4 joules. What is the length of the pendulum if its frequency was 0.75? So here, frequency is 0.75, which means the time is 1 over 0.75, which means the time is 1.33 seconds. But time equals 2 pi root L over G. So that means, let me see, 1.33 over 2 pi squared equals L over G. So then if I bring the G up here, I can calculate the length. So here the length would be 44 centimeters. What would happen if you replace the bob with someone with the same shape and size but twice the density? So what would happen here if I replace this with one which is the same shape and size but the mass or the density is twice as big? So what would happen to the time? Will it get bigger or smaller or stay the same? Smaller? Smaller? No, it'll stay the same.
Mass is double.
Yeah, if the mass is doubled, tell me. No. Tell me how this formula changes if the mass is doubled. Huh? It doesn't. Do you need to use the mass in this formula? No. So the mass is not important for the time. So in fact, the answer is it doesn't change. It stays the same. And then finally, J, what would happen to the time if the amplitude was halved? So what would happen to the time if the amplitude was changed to 0.035 over 2? What would happen to the time? Again, for the same reason, it will stay the same. The same time again. Huh? Exclamation mark.
Doing again?
No, it means this.
Here.
Hmm?
So that test tomorrow is going to be higher.
The test, you had a week to study for it. The test tomorrow will be on everything we've done.
I know it's going to be high.
It'll be fair. Okay. Next topic now.